Hey everybody, it's Pete Hatton here. So what we're going to do is we're going to calculate retention factor and explain the properties of it. All right. Here we've done some paper chromatography and you see that this may be going on, they may be done. It's hard to tell where the solvent is. And if you were to do it in calculations, they would be a retention factor calculations on these. To do them, you really need to measure something about your solutes. And so it's often called the RF value, all right, but that's what it means, or what it stands for, the retention factor. You need to measure two things. You need to measure how far the dye went and how far the solvent went. We'll just say the solvent went to there, all right? Those are the two things you need to uh, measure because there is our formula, all right, for RF values, all right? The dye divided by the distance of the solvent. Here's an example, all right? I had this paper chromatography, and here's the three things. Here's how far everything went. So my RF value for my red would be 3.1 divided by 8.5, and that's going to be roughly around, or rough 0.36, all right? And if I would do it with the blue, I'm going to use the same denominator but a different numerator, and I'm going to get a different RF value. And you should notice two things about your RF. One thing you should notice, and one thing that you should be able to figure out on your own. What do you not see over here? All right. And you don't see units because it's unitless. And it should be less than 1. Your dot should always not travel any further than your solvent. There's a problem if you're measuring that wrong. All right, so it should definitely be less than 1. All right. Now, the retention factor depends on a couple of things, and we're just going to talk about them. What do you see here? You see 3 different liquids, and this one has a different concentration. All right. So whatever you're using for a solvent will dictate or influence your RF value for your different solutes that you use. So what you wouldn't expect them to be the same because your different solvents are going to have different polarities and therefore affect the solute in different ways. Now, the chromatography paper that you're using or the stationary phase at which you're using, in this case is chromatography, is going to have some things. One thing about it is the thickness of the paper, all right? It's not all the same. It's not going to be uniform thickness. So that's one thing that's going to affect it. There might be some molecules in this itself in terms of water content of the paper may absorb some from the air. But that's it itself is going to influence whatever your RF value ends up being. All right. Now, another thing that'll influence is how big you made your spot. All right. So if you're comparing like person to person, you would expect them to be a little different because it's almost impossible to get these spots to be the same unless you're having a machine do it. Even there's some error. All right. And finally, look at that. Here's me with my hand. The temperature of the room or the temperature of your system, and it's not moving away. I didn't animate that. There should be temperature underneath there. Here, we'll do this. Temp. Okay, temperature. That's going to influence your RF value. All right. I hope this has been helpful, and I will see you soon. Okay, bye.